Now for the third type of convergent plate boundaries. And this is when two pieces of continental lithosphere come together. When two pieces of continental lithosphere come together, one of them was probably attached to an oceanic plate, which was subducting. But once the two pieces of continental lithosphere come together, both of them are too buoyant to be subducted. They're not dense enough. They're not going to be subducted into the mantle or the asthenosphere. So what happens is these two just kind of come together like a car crash. They just ram into each other, and everything that's in between them is getting pushed together, and large mountain ranges are being pushed upward when this happens. And you can see that if these all started out as horizontal layers of rocks, all of a sudden those rocks are getting convoluted into all different sorts of shapes because of the impact over time of these two pieces of continental lithosphere colliding with each other and building mountains. Just a bit about rocks. We're not going to talk a lot about rocks in this class, but I did want to introduce a couple. Let's talk about a couple of metamorphic rocks, because metamorphic rocks occur in this area here. One place they can occur is in an area like here, where the pressure is just so high that rocks are actually recrystallized. And this is an example of a rock called gneiss, which is spelled with a G, G-N-E-I-S-S, two S's at the end, so G-N-E-I-S-S. And this is a rock that has been put under extreme pressure from the right and left side here. And the minerals that you're seeing in this rock have actually recrystallized into this pattern that we're seeing here. And this occurs in places where continental collision occurs. This is another example of a metamorphic rock that could occur in an area like this. The black rock over here is called slate, S-L-A-T-E. And the slate, when all of this pressure, when two continents collide, causes the even little pieces of mud-sized particles to align, and slate breaks into very flat, even pieces, which is why it's sometimes used for roofing, as shown in the center, or for ornamented displays outside, such as here, even for pool tables, because pool tables have to be very flat, and there's a piece of slate under a lot of especially older pool tables. And one other type of metamorphic rock I would like you to know about is this metamorphic rock called marble. For marble, you have to start out with something, this is called limestone. You can think of it as a piece of chalk for now, but if we took something like a piece of chalk and we put it under extreme pressure, what would happen would be that it would recrystallize, the actual mineral in there would recrystallize into something called marble. And marble is often used for decorative tiles or in bathrooms or swimming pools because it has pretty patterns associated with this recrystallization. Marble or limestone also both will fizz if we apply hydrochloric acid to it. It undergoes a chemical reaction, and that's one of the ways geologists determine what type of rock this is. They would put a little drop of acid on either a limestone or over here a marble, and the marble would actually fizz. And that's what this rock once again is called, marble, which is spelled M-A-R-B-L-E. So one famous example of when two pieces of continental lithosphere collided was India colliding into the Eurasian continent and forming the Himalaya mountains. So this showed what happened in the past. Here's the divergent plate boundary here. The continent of India is along for the ride here as it's moving to the north, and the oceanic lithosphere on its other side is getting subducted underneath the Asian continent. At that time, there would have been volcanoes in this area, but once India and the Eurasian continent start to collide, there's no more oceanic lithosphere to be subducted, so the volcanoes kind of turn off, and the highest mountains in the world were built during that time, the Himalaya mountains. So the Himalaya mountains were formed by continental collision of two tectonic plates, and these are the highest rocks in the world. If you climb to the top of the Himalaya mountains, there would be limestone there. So that's a rock that was deposited when at sea level, and now it's the highest rock in the world. That gives you some idea of what these tectonic forces are like over time.